We will continue the same as the previous lesson and the remaining part of the momentum, and again we will explain what is momentum, and especially we will talk about momentum before and after collisions. Okay, so that's why we will have one specific title for this one, and that is conservation of momentum. We will talk about this too. So here we have some key points that today we will talk and we will learn. Inshallah, the first one is defining momentum and calculating the using mass and velocity. Again, we will use the same formula of the momentum, which is mass and velocity. And next one, we will talk a new title, which is impulse. Impulse is force times time, and applying the principle of conservation of momentum, as we know that the momentum before the collision and after the collision will remain the same but with different it is in a different system that we will talk about this one. And the final, we will talk about solving multi-steps collision problems, and we will solve the different types of questions. And key vocabularies, we are having momentum, impulse, and closed system. All are very important. So what is momentum? The quantity of motion a moving object or body has. Yeah, as you define the momentum, that's exactly the definition. Impulse, what is impulse? Impulse is a change in momentum caused by a force over time. For example, if you consider how much force does the moving object has and how much time will it take, so if you multiply these two quantities together, then you will finally find what? Impulse. So force times time is equal to what? Again, the momentum. Usually we have two types of system. One is closed system, one is open system. Closed system is the system that we usually do not think or consider the effect of frictions. For example, gravity, friction force, and the air resistance when we are counting or calculating the momentum. But the open system means that open system we should consider everything, the effect of everything on momentum. For example, when we are applying when we are using calculating the momentum, so we usually do not consider the air resistance, but in practical air resists and air try to stop the moving object. But here we usually, because we are in the basic and we are in the foundation and we are not having enough information about the momentum and impulse, so that's why we only think as a closed system, not as open system. Okay, so let's move again step by step with momentum, and do check it, and if you face any types of problems, so you may ask me. Okay, first, as we defined in the previous lessons, what is momentum? Momentum is the quality which a moving object has. For example, it is directly related to the mass and then the velocity of the moving object. Velocity. Okay, so what is the unit of momentum? It is kilogram meter per second. We have two objects here. One is very small and the next one is big. Okay, so the amount of mass in the first object is not too much, but the velocity is too high. But in the second object we have two heavy objects and the velocity is not very high. But again, if we check stopping both of them, the first object and the second object are very difficult because they are having the same momentum. For example, if you check the first object, the mass of the first object, for example, only 1 kg, 1 kilogram. And if you check the velocity, for example, velocity is equal to 2000 meter per second. And if we count momentum of this one, m times v. So how much will be the momentum of this one? Momentum will be 1 kg times 2000, for example, meter per second. So what will be the result? The result, we will have 2000 kilogram meter per second. So this is the momentum of this object. What if we think that, for example, here we have one object which is having mass of, for example, 1000 kg, and this object is moving with the velocity of 2 meter per second. And if you find the momentum will be equal to 1000 kgs times 2 meter per second. And finally the result will be the same, 2000 kilogram meter per second. So the momentum of these two are the same, these two objects are the same. That's why and it is very difficult to stop both of them. Okay, so this was the momentum as we used in the previous sessions as well. Okay, now come to the new title, which is impulse. Okay, we have one new expression, and this expression is impulse. What is exactly impulse? Impulse, based on the physics, is equal to what? Force multiplied by time. And the result of force multiplied by time is equal to what? Momentum. Changes in momentum. So you can find delta P, or momentum, by this formula. Delta P is equal to force times T, and then you can find momentum. For example, P is equal to M times V. Okay, so for momentum we can use these two, both are equal. Okay, if we consider what the mass of the moving object with the velocity of the object, then we can find the momentum by this formula. But what if we have force of object and with the time that this object may take to collide or to hit something else? Okay, so that's, we call them what? Impulse. We use both of them to calculate or to count some practical examples. For example, now here you have for example a ball, and when you hit the ball and you apply, for example, a specific amount of force, and when you hit the ball, so the ball may come and hit another object. For example, how long it will take to hit or to collide to another object, that's called delta P. So delta P, and here we exactly call them impulse. Okay, so here is the definition of impulse: the change in object's momentum. The changes in object's momentum, you must apply a force over a period of time. Okay, changes of momentum over a period of time is called what? Impulse. This is called impulse. Impulse is changes of momentum during a period of time. Okay, here see that we have Newton's third law and collisions. Okay, do you remember what was the Newton's third law? If you remember, you may open your mic and explain. Newton's third law and collision.
Actually, I think it was action and reaction, that every action there is an equal and opposite reaction.
Yeah, that's the case. Okay, so now see that how important is the third law of the Newton. Now in momentum we use the third law of the Newton. We simply studied in the physics in the previous chapters that it is the third law of the Newton is the law of action and reaction. For example, when you force and when you apply force one object, and the same object may apply the same force but in the opposite direction. Now see here we have we have these two objects and they are colliding each other, so these two objects are producing what? Reaction. For example, first this object may move from this direction to here, and again this object is moving this direction. But what will happen if they collide each other? Okay, so the action which will be produced by this one and the same action will be produced to other body. For example, this is the first and this is the second body, and for example the first body may produce force on the second and the second produce may the same force on the first object. So it depends on their mass that they have. For example, m1 and m2, it depends on the mass that they are having. If we think that m1 is equal to m2, so the same reaction may cause the first object to move in the left side and the first object to move in the right side. This is the exact meaning of the third law of Newton. Okay, so this is the law of action and reaction. In the left bottom part of the slide, we have that when two objects collide, they exert, means that exert equal and opposite forces on each other. So this is the definition of the third law of Newton. Okay, because the collision's time, okay, is identical for both, so the impulse is identical for but opposite. Okay, so what laws, for example, what A loses and B gains. For example, so what does it mean? For example, the time of collision is the same, and when they are hitting each other, so they produce the same action and reaction on each other. Okay, so now come to another very interesting title. Okay, so here we have this title: momentum B for the collision and is equal to momentum after the collision. So this is called what? The golden rule of the closed system. A closed system means to external no external force like friction, air resistance, or interfering. The total energy and momentum are locked inside the interactions. Okay, so here we have this. 1 minute, let me write and then I will ask you some questions. For example, this rule, momentum before the collision and momentum after the collision, they are called what? Momentum conservation. Momentum conservation. Momentum conservation. Okay, so now we will talk about the system. System will be explained, but before the system, what is the exact meaning of conservation? If you know anything about this, and even in Persian, if you are able, you can explain in Persian as well. Okay, what is the meaning of conservation?
I think that it means a person or organization legally supported by a court or like managing.
Conservation. Could you explain it again? Try to make it a bit simple if you are able to explain, and if you are not able, then you can use in Persian. Okay, so momentum conservation, if we exactly understand the meaning of this title, then easily we can understand and we can solve the questions.
Yeah, so I think that I say that it is the total momentum of an insulated system that remain constant.
Remain constant, or remaining the same momentum before and after collision. Yes, Ms. Ilahan Auruzi, you may continue.
Okay, sir. Conservation means that a certain quantity stays constant and is not lost or created, although it can change form or move from one object to another.
Yes, that's exactly the definition of conservation. Okay, conservation means that if the amount of something won't be changed and if it remains the same, we can call them what? conservation. So conservation, we have different rules. For example, force conservation, mass conservation, and we have different conservations in different subjects. Okay. For example, when you talk about the chemistry, in chemistry when two, for example, two elements combine with each other and make a new material and compound. So for example, the amount of mass before the reaction and amount of mass after the reaction, they will remain the same. So the role of mass conservation in chemistry is one of the most and the best role in chemistry, because the mass before the reaction and after reaction will remain the same. And here we have the same amount of momentum will remain the same before the collision and after the collision, but there is one exception. Okay, so in this the exception tells us that we should always think that the system must be what? Closed system, not open system. In closed system, everything will be considered as zero. For example, in closed system we will not have air resistance, in closed system we will not have friction force, and we will not have any external force. We think all of them equal to zero. But in closed system is equal to zero, but in open system everything is having their own real reaction. Okay, so that's why we will talk today about the conservation of momentum before and after the reaction, after the collision. Here, for example, here we have one example, but this example is very interesting example. For example, before the collision, if you have one object here, this object, let me to change the color of my pen, then we will come here. For example, this is the first body. Okay, this body is moving from the left to the right side, and the mass of this one is called what? m1, and the velocity of this one, because it is the first velocity, and we can call them u1 or initial velocity. And but what is what is the second? The second body is, the mass of second body is m2, and the velocity y, because this object is what? Static or stationary, doesn't move, and the velocity is equal to 0. So let's count their momentum. Momentum of the first object, m1 times u1 plus m2 times u2 is equal to what? For example, if the m1 collides m2, so we will have this part of the equation. We will have this part, and see that if the static object hit by for example moving object, so we will have the momentum of this one will be m1 times v1, because v1 is the second velocity or the final velocity, and the momentum of this object will be m2, because this object is not anymore static, it is moving, m2 times v2. But what if we add them, so this will be now see that what is very important here. This is very important, that the velocity of these two objects after the collision will remain the same. For example, so this object was moving and the second object was constant or static. When the first object hit the second object, so they move with the same velocity, so we will be the same, v1 will be the same as v2, so we will think as what? v1. So this will be the result of this one. Let me write it here. Okay, the first one, m1 u1 times plus m2 u2 is equal to what? m1 plus m2 times v1, because v1 is the same for both of them. If we take as a factor out of the parenthesis, then we can say like this one. So this formula is exactly called what? Conservation of momentum. Conservation of momentum. Conservation of momentum explains that the amount of the momentum before the collision is equal to the amount of momentum after the collision. So here we have one very nice example. Then let's explain this example. I will to solve this example for you, but I have 3 more examples. You may do them yourselves. Okay. So here we have 2 objects. For example, here is car A and we have car B. And the car A is moving, and car B is what? Static, means that it is stationary, it doesn't move. And let's see, for example, when the first object or the first part of the car may move from this one and come and hit car B. What do we have here? For example, the mass of the car A is, for example, mass of car A is equal to how many kgs? We have 5,000 kgs. And what is the velocity of this car? We have VA is equal to 3 meter per second. Okay, so let's do check, and we should find the momentum of this one, or we should find with this one the momentum of this one before the collision. For example, how much is the mass of this body? AB is equal to 10,000 kgs. And then we have how much is the velocity, because it is constant. So we should think that how, for example, u2 sorry, let me write like this one, ub. Okay, so ueb, and here also let me write, because this is the initial velocity, ua. And let's find their velocity, this one, the momentum before the collision. Okay, so let me write it again. MEA is equal to 5,000 kgs. UEA is equal to how much? For example, this is 3 meter per second. And then we have MB. MEB is equal to 10,000 kgs. And UEB is equal to how much? Equal to 0. Okay, so let's do count it before the collision. So here we have MEA VA plus MEB or UB. Okay, so let's count it. MEA is equal to 5,000 times how much is UEA? UEA is 3 meter per second, plus MEA is 10,000, MEB is 10,000 meter per second, times UEB is equal to how much? UEB is equal to 0. So we will have 5,000 times 3, we will have 15,000 kg meter per second. Okay, so this is the momentum before the collision. Okay, so let's count the momentum after the collision. So here let's do check it. Okay, so after the collision we will have ME1 or MEA is equal to how much? 5,000 kgs. But UEA is equal to VB, but it is not clear because we don't know how much will be the speed or the velocity after the collision. But we have MEB is equal to how much? We had 10,000 kgs. Okay, so let's write it. We had MEA VA plus MEB times VB equal to, okay, so MEA and MEB, this one VA and VB is equal, so instead of VA equal to VB, we write only what? V. Okay, so V is equal to for both of them, and we take as a factor MEA plus MEB inside the parenthesis, and out of the parenthesis we will have V. It will be equal to, okay, so let's write the value of each one. V is 5,000 plus VB is 10,000 times V. Okay, so here we will have momentum after the collision. We will have, for example, 5,000 plus 10,000, we will have 15,000 V. Okay, so this is the momentum after the collision. As the rule of momentum conservation of the momentum, we have what? Momentum before the accident or collision is equal to momentum after the collision. Okay, so here we had momentum before the collision was, how much was this one? 15,000 kgs meter per second is equal to 15,000 V. Okay, so V is unknown and we should divide over the factor of V. 15,000 and 15,000. So finally V will be equal to 15 over 15. It will be equal to 1. So the speed of the velocity of the moving object after the collision will be how much? 1 meter per second. Any question, any problem? So this question is also solved in here. Here we have till this point. Okay, so till this point we have the accident, the momentum before the collision, and here we have the momentum after the collision. Okay, so both are equal. For example, before and after the collision, because they couple together after impact and their masses combine into a single moving object, so they are moving at the same velocity. So finally, if we apply the same, for example, values for each other, finally we will have 15,000 is equal to 15,000 V. And finally, if you want to find V will be equal to 1 meter per second. So this is the final velocity of the after the collision. So this is one of the most important role for momentum conservation. Okay, now I will have 2-3 examples for you. You may do check it and which one can you solve. The questions will be the same as we applied here. Yes, Ms. Amiri, if you are having any question, you can ask.
So actually the main purpose of this formula to find the velocity after collision.
After the collision you can find velocity, you can find the mass as well. For example, in this example the mass was known and the velocity was unknown, and we just found the velocity. For example, sometimes you may have the example the velocity is clear. For example, the object is for example moving after the velocity, after the accident or collision. Object is moving with 1 meter per second, and the mass of one object is for example 10,000. You may find the mass of the first object. We can find differently. We can find different part of this equation. Okay, so in this example we found only the velocity, but it is possible to ask you to find the mass, to find the for example velocity of velocity before the moving before the collision differently. You can the questions can be different. Okay, any other question? Okay, so if there is no question, I will give you 3 examples. You may do check that which one can you answer, or you may do solve and try your best. Based on the rule of this question, you can answer one of those 3 questions. 1 minute, let me to find the example. Okay, so as you can see that here is we also having the momentum, and momentum, this is the role, for example before the accident, and we are having after the accident. Momentum demands absolute equilibrium, means that the role that we are having, it means that here we have one scale, means the amount of momentum before the accident. So here we have for example before the collision, for example here the amount of momentum before the collision will be equal to the amount of momentum after the collision. So here we have what? Here we have the scale. This is the scale, and this scale shows what? Momentum conservation. Momentum conservation. Okay, so here we have for example momentum before the accident or collision, and in the second part, in the second phase, we have momentum after the collision. And here exactly the structure and the formula is given to you: amount of momentum before collision and after collision. So here we have one example. For example, reading the visual dashboard. So here, yeah, this is one example, after and before the collision, and next one here is the example. You may do check this information. For example, a 1200 kgs car moving at 20 meter per second strikes a stationary 1800 kgs car, and result they lock together. It means that they move at the same direction, creating a 3 kgs mass moving at for example 8 meter per second. So you may consider this one as do not think that how much is your final velocity. So based on the formula, you may count how much will be the final velocity of the moving object after the car accident. Okay, do check this part of the question. Okay, so you have 2 minutes time or 3 minutes time to do answer this question, and then we will have one more question to solve it.